Suppose the newspaper states that the probability of rain today is 20%. The first question we're asked is, what is the complement of the event rain today? Well, let's let A be the probability or the event of rain today. The complement is the event with a superscript C. And that's the event of no rain today. The probability of event A was 20%. Probability is expressed as a number between 0 and 1 inclusive. So your 20% in probability form would be 0.20. Because the event of either rain today or no rain today must occur, the probability of an event and its complement must add up to 1. So if there's 20% chance of rain today, then there's an 80% chance or 0.80 probability of no rain today. What is the probability of an event that is certain? That's 100%. An event that is impossible is 0. Those are your extreme values for probability. 0 for an event that's impossible, 1 for an event that is certain. What is the law of large numbers? As your sample size increases, the relative frequency of outcomes gets closer to the theoretical probability of the outcome. A quick example of this, if you were to take a quarter and flip it repeatedly, your first 10 events, you may flip 7 heads and 3 tails, but because the probability of heads and tails is 50-50, if you flip that coin 100, 200, even call it 500 times, then you go back and count, you will start getting closer to a 50-50 probability for heads or tails. So the larger you make your sample size, the closer you'll get to the theoretical probability of the outcome. And it's just like if you rolled a die, each face has a 1/6 probability of coming up. If you were using the relative frequency of an event to estimate the probability of the event, it would be better to use 500 trials because the law of large numbers would take effect. A recent survey of 1,050 U.S. adults selected at random showed that 625 considered the occupation of firefighter to have very great prestige. Estimate the probability to the nearest hundredth that a U.S. adult selected at random thinks the occupation of a firefighter has very great prestige. Okay, probability is defined as number of successes, which in this case would be 625 out of 1,050. The denominator is the grand total of possibilities. The numerator is the success. Rounded to the nearest hundredth, if we divide these, we get 0.595. Rounded would be 0.60. So about 60%. On a single toss of a fair coin, the probability of heads is 0.5 and the probability of tails is 0.5. This goes back to earlier, the 50-50 chance. If you toss a coin twice and get heads on the first toss, are you guaranteed to get tails on the second toss? You would not, because each outcome is equally likely regardless of the previous outcome. Also mentioned on the first slide is the probability of the probability of an event must be a number between 0 and 1 inclusive. Isabel Briggs Myers was a pioneer in the study of personality types. The personality types are broadly defined according to four main preferences. Do married couples choose similar or different personality types in their mates? The following data give an indication. We have a table of similarities and differences in a random sample of 375 married couples. Suppose a married couple is selected at random. Use the data to estimate the probability that they will have 0, 1, 2, 3, or 4 personality preferences in common. Enter your answers, which this is for WebAssign. We're going to round our probabilities to 2 decimal places. Okay, so there's 375 total. Number of similar preferences for 0 is 39. $39 out of 375 is 0.10. It's actually 0.104, but rounding to 2 decimal places. Okay, the probability of one similar preference is 64 out of 375. That is 0.17. For 2, it's 121 out of 375. I get 0.32. For 3, it's 125 out of 375. I get 0.33. And then finally, for 4 similar preferences, all 4, it's 26 out of 375. That is 0.07. Do the probabilities add up to add up to 1, and why should they? If we add up 0.10, 0.17, 0.32, 0.33, and 0.07, we do get 1. I mean, it actually comes out to 0.99, but that's due to rounding errors. So the answer to this would actually be yes. If we'd have gone to all 3 decimal places, they would definitely add up to 1. Again, that's due to rounding. But all of the sample space is covered. We've calculated the probability of every event in the table. These values up here, if you were to add them all, you would get 375, and that covers everybody in the study. What is the sample space in this problem? The sample space is all the probability, personality preferences that married couples have in common, and that can go from anywhere from 0 to 4. As long as you cover all possibilities out of your table or data, the probabilities have to add up to 1.